Hello, everybody. Welcome to the new homework help for 2.4. They changed what was happening in the new printing, so let's go over the new stuff. All right, so the sequence below exemplify either an additive, which is arithmetic, or otherwise known as linear, or multiplicative, or geometric, otherwise known as exponential. Pattern. Identify the type of sequence, fill in the missing values on the table, and write an equation. So we can do that, no problem. So let's see what we have. We start with 2, 4, 8, 16, and 32. So is it additive? Are we adding the same number? Well, here we added 2 to get 4. Here we added 4. Here we added 8. So it's not going to be additive. So it's going to be multiplicative. And in fact, we can see that what we're doing is we're multiplying by 2 each time. Times 2, times 2, times 2, times 2. So if I do it again, the sixth term would be 64. This would be, what, 128. This would be, what, 256. Okay? And so our equation, we remember from our geometric sequences that we have f of x equals n sub 0 times our common ratio to the x power, or n sub 1 times our common ratio to the x minus 1 power. Now we have our first term. This is our n sub 1. This is our n1. So I can use that. So our equation is going to be f of x equals 2 times, in our common ratio, we're doubling each time, so 2 to the x minus 1 power. That's our equation. If we were to go backwards and think about what our 0th term would have been, our 0th term would have been 1. So we could have also written it as f of x equals 2x. Let's do one more. Let's look at number 2 here. So we have 66, 50, 34, 18. And it looks like we're subtracting 16 each time. So if I were to subtract, so this is going to be additive. And if we're subtracting 16, 18 minus 16 is 2. 2 minus 16 is a negative 14. Negative 14 minus 16 is a negative 30. And then negative 30 minus 16 is going to be a negative 46. And then our equation for arithmetic is f of x equals our n sub 0 plus our common difference times our x. Or if we have our n sub 1, it's the common difference and then x minus 1. We have our n sub 1 here. So our n sub 1 is, what is that, 66. Oops, f of x equals 66 plus our common difference. But this time our common difference is a negative number. So it's a negative 16 x minus 1. Oh my gosh, look at this. This looks so ugly. Let's clarify this. So we'll say it equals 66 minus 16 x minus 1. And we can do the n sub 0 if we work backwards, right? If we're subtracting 16 each time, if we were to go back, our 0th term would have been 66 plus 16, so that would have been 82. So our 0th term would have been 82 minus 16x. All right? And this is just kind of a more elegant way. The n sub 0 always looks a little bit more elegant. So that helps with that. All right, that's our ready. Let's go to set. Or is this still ready? Yep, it's still ready. Okay, so this is great. So it says use the graph of the function to find the desired values of the function. Also create an explicit equation for the function. We can do this. So it says find the value of f of 2. So f of 2 means what is the y value when x equals 2, right? What is the y when x equals 2, right? Because normally it's f of x, but we're putting 2 in for our x, all right? Whoops, I've got a little smudgery now. All right, so let's find 2. 1, 2. So this is 2. F of 2 is wherever it crosses the line here, and it crosses the line right here. So f of 2 would be whatever our y value is. So f of 2 equals 2. Okay. Let's do this one. It says where f of x equals 4. So f of x, the x isn't given, but the y value is. So here's where f of x equals 4. So we have to find where it crosses. It crosses right here, and it crosses at 4. So f of x equals 4 is x equals 4. That's where that happens. All right. Find the value of f of 6. So this time it's 6 in for the x. So let's go up to 6. We see that it crosses right here, which is at 8 equals 8, etc., etc. Okay. And there we go. That's going to be our pattern. It wants us to find out what the explicit equation of this is. And so what we have to do is this is kind of a table, right? We know that here's 0 is 1. So in x, y, 0, 1. At 2, it's 2. At 4, it's 4. At 6, it's 8. So we can kind of figure out what our difference is. We know it's a curved line, so we can use our geometric means to be able to find that. We can use geometric means to figure it out. So to go from 1 to 2, well, to go from 1 to 2 over 2, right? It's because we're going over 2 here, right? Every step of 2 we're doubling. Every step of 2 we're doubling, right? So if every step of 2 we're doubling, you know, this creates a little bit of a problem, because we know that x2 minus x1, y2 over y1. Okay, so let's just pick 2 points. Let's call this point 1, and let's call this point 2. Okay, so it's going to be 8 minus 2 root, right? No, oh, I'm sorry, I did my y's on accident. 6 minus 2 root of 8 over 2. 6 minus 2 is 4th root of 4. Ooh, that's going to be tough. That's going to be real tough. What's the 4th root of 4? So we might need a calculator for this. Let's see if we can do it a little bit easier, though, right? Let's see if we can do this with our classic table, okay? So what we have here is we have at our x and our y, we've got 0 and 1. We don't know 1. We know 2 is 2. We don't know 3. And we know 4 is 4. We don't know 5, but we know 6 is 8. And so what I want us to see here is we have 1 times 2 to get there. And then this is also times 2 to get here. And this is also times 2 to get here. But what do we have to do to multiply to get here, and here, and here, and here? Like this. What are these smaller factors? What are these smaller factors to get here? So let's find out. So we know that 1, and I'll call these, I don't know what to call these. I'll call these h's for half steps. So 1 times h times another h is going to equal 2. So I know that h squared equals 2. So I know that if I square root both sides, h equals the square root of 2. So actually my growth factor at every step is the square root of 2, because it's going to be square root of 2, 2. This is going to be 2 root 2, 4. 4 root 2, 8, etc., etc. So I know that my geometric means, I know that my growth factor is the square root of 2. So what that tells me is if I have to write this equation, it's like, okay, well, now that I know that this is my common ratio, and I know that n sub 0 times my common ratio to the x is my equation, this is my f of x, well, my n sub 0 is 1 times my common ratio, square root of 2, to the x power. So in fact, that's what this equation is. This is the square root of 2 to the x power. Next section. Okay, it's asking us to do more of this. It's asking us to figure out more of these in a defined table. So let's go ahead and do that. So it's tripled at each whole year. So 2 is tripled to 6, is tripled to 18, is tripled to, oh boy, what's 18 tripled? 18 tripled, 1624, 354. 54 tripled is 162. Okay. And so now we have to figure out what we're doing at each step. Well, here's the thing. If we're tripling it at each step, if this is times 3, this has to be what number times itself is 3. So h squared equals 3. So these little half steps, h is going to equal the square root of 3. So this is going to be 2 root 3, 6. 6 root 3, 18. 18 root 3, 54. 54 root 3, 162. Here it's asking us to do it again, except this time we're doing each third step. Right? Here we're doing each third step. So again, this is still tripled, but we have to do it 1, 2, 3 times, 3 half steps. So half steps cubed equals 3. So then we take the cube root of both sides, so that h equals the cube root of 3. So this becomes 2 cube root 3. This becomes 2 cube root 3 squared. And then boom, 6 cube root 3, 6 cube root 3 squared. And then that'll be 18. 18 cube root 3, 18 cube root 3 squared, etc., etc. Finally, go. It wants us to simplify these. Here are your basic rules when it comes to this. If we're multiplying across like this, what do we do with our exponents? We add them together. So this becomes 3 to the 7th. And why is this true? Well, think of it this way. 3 squared is 3 times 3. 3 to the 5th is 3 times 3 times 3 times 3 times 3. So we've got 1, 2, 3, 4, 5, 6, 7 3s, 3 to the 7th. When we're dividing, well, look at what happens. When we multiplied, we added. So when we divide, we subtract. This is really small. Let's zoom in. So we subtract 3 minus 2, so this becomes 5. How does that work? Well, what's 5 to the 3rd? 5 times 5 times 5. And then 5 squared is 5 times 5. So these cancel out, leaving us with just a 5. 2 to the negative 5, anytime we have a negative exponent, that just means we put it in the denominator. So this is the same as this is the same as 1 over 2 to the 5th. Anything to the 0 power by rule is 1. This one is combining both 15 and 16. So 5 divided by 2. 7 to the 5th divided by 7 to the 2nd means 5 minus 2 is 7 thirds. 7 thirds, 7 fourths, 7 to the minus 1. We add these together, 7 squared. And then this one's a challenge one. Have fun with that. All right, that's going to be it for today. I'll post this, and I hope you have a good time doing this.